Good morning. Mr. President, ladies and gentlemen, I would like to thank the committee for inviting me today to give the Atkins Memorial Lecture for 2007. It is an immense honour for me to follow so many important people of the industry who have delivered this lecture in the past. I did question at the time if I was last on the list of possible candidates for this lecture, and others being busy this year. It was told quite clearly that I was at the top right from the start. This goes to show if you hang around long enough, you rise to the top by seniority. W.R. Atkins, a colleague of Proctor in the leather department at Leeds, was a man who advanced to the top of his profession by study and research. Co-author of Proctor's classic Leather Chemist Handbook, Atkins strongly influenced both research and teaching between the two wars. Atkins' ability in transferring scientific knowledge gained from research into day-to-day practical use was a feature of his success. Atkins' time at Leeds, in the chair at Leeds, however, was tragically cut short as he died during 1957 after serving only 1 year in that position. It is indeed a privilege for me to be here today on this, his 50th anniversary of his death, and I hope the paper I have prepared will be worthy of Atkins' illustrious name. The transformation of hides and skins go through, preparing them for tanning, are clouded with tradition. But put simply, an explanation could be Beamhouse processing is principle one of purification. The hides and skins are prepared for tannage by mechanically modifying the structure while chemically isolating the leather making protein. It is widely accepted that leather is made or marred in the Beamhouse, and that Beamhouse processes are the base or foundation on which all other processes are built. While substantial technical advances have been made in other areas of the tannery, the Beamhouse process has remained much the same as they were 120 years ago. Of course, there have been considerable changes, many of which I will touch on today, but the base of all hair removal and fibre separation is still lime and sulphide. Beamhouse processing involves a number of steps, many of which have become combined over recent years. This stage of leather making, because of its nature, receives limited day-to-day technical attention. At best, the Beamhouse is a dirty, smelly and often cold, a somewhat unpleasant place to work. Consequently, the standard of personnel working in this area is often not the best. I have sympathy with comments made by Paul Smith, an American chemist, in 1942. The limeyard foreman has a most responsible position, but too often he is ill-prepared for his job, which he works by rule of thumb. Smith had touched on a problem in the tanning industry during that time, the role of a pure chemist in what is basically a craft industry. He added, the root of the trouble lies in the jealousy which exists, though seldom apparent, between the practical and fully experienced tanner and the academic chemist, who is mercilessly dubbed theoretically, a term that has become almost a sneer. This mistrust between applied science graduates and experienced tanners was still widespread at the start of my career in the industry. Maybe this rivalry was one of the reasons why the name of this society was changed from the Society of Leather Trade Chemists to the Society of Technologists and Chemists in 1973. The name Beamhouse came from the tanner's beam, a round sloping bench on which the tanner worked the hides and skins during preparation for tanning. The men who worked on the beams were very skillful, as damage to the hide were comparatively easy during these operations. Working with beams had discontinued by the time I started work in 1952, but they're still there in the corner of the warehouse, and I was told they'd been used up till 1950. In latter years, I saw beams being used in Pakistan for fleshing and was fascinated to see the skill involved, but horrified with the time that was needed and the number of people required for even a medium type production. I started as an apprentice in a beamhouse of a traditional glassy kid tanner almost 55 years ago now. While to me this doesn't seem such a long time, the world and the tanning industry have changed substantially since then. It is maybe interesting for you to hear how it was for a young boy learning the trade of tanning over 50 years ago. The preparation of this paper has reopened many doors in my memory I thought had been shut forever, and my recollections have tended to fall on the pleasant side of working away from the often harsh life it really was. So please excuse me for these memoirs of an old man. Employment in my hometown, Northampton, after the Second World War was dominated by the tanning and shoe industry. It was almost accepted I would work in one or the other industry after leaving school. My latter school years were spent in the technical high school, situated in what is now the St George's Avenue campus of Northampton University. The building at that time also housed the Northampton Leather School, as well as a large shoe training department on the lower floors. To be really honest, the main reason in the beginning for visiting the lower floors of the school at all had more to do with the bacon rolls available from the canteen beside the leather school, more than the thought of becoming a tanner. At this time, my uncle, Bill Pepple, who some of you may have known, was a mature part-time student in the leather school, having spent most of the war in the army. He encouraged my interest in what he was doing in the trial tannering. Having lost my father during the war, my uncle had taken me under his wing a little bit and continued to do so for the rest of his life. It was he who eventually suggested an apprenticeship in a tannery would be a good start to working life. So on December the 27th, 1952, I started what was to become a long and fulfilled working life in the leather industry. Following British Chrome's demise in 1970, having worked there for 18 years, I joined a chemical company handling chemicals for Siemens-Heiliger, with whom I still work. Working with Siemens-Heiliger has involved extensive travels around the world to countries I only dreamed of when I was first started in the Beamhouse at British Chrome. Siemens-Heiliger employed me as a technician to demonstrate the range of chemicals they produced. It was still new in time to have technical people in our industry, technical salespeople in our industry. In British Chrome, we almost never had technical people visit us, and those that did were seldom allowed in the factory anyhow. Chemical companies had commercial representatives, reps, who called regularly, taking orders, supplying rugby tickets and the like, and known collectively as suppliers. To a tanner in my early days, the word rep or supplier was almost as derogatory as heretical was to the chemist. Recently, I was with a group of people at Leather Sellers Hall, some of whom were not from the industry. I was introduced to one such lady who asked which tannery I was working with. Someone in the group quickly answered, "Oh no, Mr. Basford is not working in a tannery, he's a supplier." The lady was very gracious and inquired, "What is it you do then, Mr. Basford? Herding the cows?" The first day at British Chrome would never be forgotten. I arrived at 7:15 in the morning, carrying a sandwich for lunch, a small shoe worker's apron with a pocket in front made for me by my mother. I was given a clock number and escorted to the Beamhouse, where I was to spend the first months of my apprenticeship. My shoemaker's apron was put to one side, not required I was told, and I was given large wooden clogs, leather puttees for wrapping around my trouser leg, and large rubber apron and small gloves. By 7:45 I was in a pit, up to my knees in poorly drained goat skins that had been laying in Puget soaking liquor over the Christmas holidays. The smell was unbelievable. Made worse by being 8 feet below the tannery floor. And these are actually pictures of the actual pits, although they were taken a little bit earlier than when I was there. But this was British Rome in 1927 on the occasion of the visit of the Duke of Wales, as was then. By 8:30, I was soaked to the skin. My arms seemed to be falling off with the effort of throwing the skins up to the tannery floor, where another apprentice was piling them to drain. As you would be expect, in the beginning, half the skins didn't make it out of the pit and fell back onto me, showering me with dirty soap water. I was really ready for a rest, but I was told I still had another hour to go before break time. At the end of the day, as I walked home, very tired, smelling like a sewer, every limb aching and very damp, I wondered had I made a big mistake in my career choice. The following morning, I was better prepared. Arrived at the tannery with working clothes to change into, a bigger lunch pack, including food for break time. A tanner I had learned needs more food to keep him going through the day. While walking to the factory, I went over my first day's work and realised, as the day progressed, I had learned to handle the skins in such a way as not to get so wet, and had also found it easier, on my arms at least, to throw them out of the pit, so I was not too concerned about my second day in the soaking pit. It was not to be, however. My second morning was spent at the end of a sulphide painting conveyor, piling the skins, painted side together until the hair was loose enough for unhairing. I was shown how to pile the skins, but no instructions or warnings about the dangers of the caustic solution used to loosen the hair. Consequently, the spots of paint that ended up on my arms, an unprotected face and neck were starting to sting a little bit on lunchtime. I discussed this problem with a more experienced tanner, all of 3 months longer, who instructed me to go to the toilet and rub urine on the sore spots, which seemed to help with the soreness, but the resulting smell was hardly worse than the sore. After painting was finished for the day and unhairing started, my afternoon job was washing and drying hair, a valuable byproduct after the war. While the job of washing and drying the hair seemed at first a big improvement on the pit or painting machine, it had its own problems. The irritation from the short hair and the sulphide and lime dust quickly becoming unbearable. On my way home, I realised, in spite of a shower and changing completely from working clothes, as I warmed up, the smell of sulphide increased to the point I smelled worse than I did before I showered. Some months later, this lingering smell of the Beamhouse was brought home to me by a barber while cutting my hair. He informed me he knew I worked at British Chrome because I smelled just like his brother-in-law. At 15 years old, this was not so much of a problem. But when females came into the picture later, it was not so good, really. At our local dance hall, a girl, who I had shown some interest in, said, while rejecting my advances, "I don't like your aftershave." But that was the first time that I'd ever heard of aftershave. The first week quickly passed. It involved getting dirtier, smellier, wetter, and more exhausted than I ever believed possible. Jobs ranging from unloading paddles, using a pole to lift the skins to the surface, while another pulled armfuls of swollen skins over the paddle edge into a bin ready for fleshing, to preparing chemicals for the next day's production. We unloaded and broke open barrels of wet salted skins from India that had set solid during transportation, and prepared skin trimmings destined for gelatin. Of course, as apprentices, we also had the task of making tea for the 50 or so workers 3 times a day, and to ensure the whole workplace was washed down every night before we left for home. This last job led my mother to constantly complain, "You boys only wanted to be tanners so you could play with water," as she tried to dry our wet clothes for the next day's work. There was a few B words installed in that, which I decided to edit out. The chemical preparation was a most unpleasant job. The solid sodium sulphide was delivered in metal drums, which needed cutting open with a hammer and chisel, and the solid block of sodium sulphide broken into pieces with a sledgehammer before boiling in a vat to prepare a standard solution. The lime, quicklime, had to be mixed with red arsenic, as the latter on its own was insoluble in water. The lime arsenic mixture was added to water in a pit to convert it to calcium hydroxide for use in the tannery. The violent reaction on adding lime and arsenic to the water produced so much heat the water boiled. As the boiling effect subsided, more quicklime and arsenic mixture was added to keep the temperature up. The end result was a thick paste that needed to be mixed by hand, ensuring no lumps of quicklime were left that could damage the skins, a job that still haunts me today due to the intense physical effort it took. At no time were we allowed to become bored. We were taught how to inspect dry salted goat skins over a light to show up damage that had been hidden intentionally with dirty salt to improve their value, and how to identify dried African skins that would be suitable for suede, as these had a special liming process. The Beamhouse process was unhurried compared to today, with 8 to 10 days being normal from pit soaking to fleshing, but all the work was manual, no forklifts, no pallet trucks, no heating and no automation. The vast workforce involved in the Beamhouse. This gives you some indication how many were. This was just a baiting department. There was 25 people in the baiting department. Pretty sure. The vast workforce involved in the Beamhouse and the severe working conditions often encountered formed a culture of mutual support, a situation I have encountered in other companies' Beamhouses throughout my working life. There was always a kettle for tea somewhere, in a place tucked away from too many eyes, where you can rest and warm up a little in this often harsh environment. An illustration of this companionship was shown the following year, the following winter of 1953. I was temporarily returned to working in the Beamhouse due to an illness of a key worker. The temperature inside the department was below zero. Little heating was used in the building as we had no doors. The men stopped work at break time, volunteering me as their spokesperson to inform the owner that it really was too cold to continue. I was very nervous going into the owner's office, but was surprised to find he understood the situation and had seen it coming. He told me, before the war, Basford, in Bermondsey, we were often very cold in the winter and would work harder to warm up. I suggest you tell the men they should try to do the same. On being told this, the men went back to work with a few mutters but no further comments. Little did I realise then I would be spending the largest part of my working life in Beamhouses of so many tanneries around the world, carrying tea bags with me, of course, providing technical service for Shimmerside Echo. Of all areas in the goat skin tannery, the baiting department had its own mystique. The baiting process in British Chrome, I found, had changed little in the factory since the factory had opened 60 years before. The baiting of goat skins was still being done in a warm infusion of dog dung, which was collected each week from the hunt kennels and fermented with lactic acid for 24 to 48 hours before use. For the month I was in this department, I was instructed in the art of baiting by feeling each skin, judging the sliminess of the grain and the tightness of the structure to air being forced through. It was later that I found out the whole process really had a clear chemical background. What was quickly made clear to me, however, was the importance of the baiting manager, who could, and often did, hold up production, because the skins, in his opinion, were not ready. Could not imagine this happening today, where production is the driving force. The whole baiting process, from lime fleshing to the final cold wash to stop the action of the enzyme, was almost 20 hours. A complete contrast to the 1 to 2 hours commonly seen in modern processing. I have often been asked during my visits to Asia, why can't we obtain the smooth, flat grain that was a feature of top-class glazed kit? And my answer was always the same: give more time, a selective treatment, and you can, but it will cost. Production was mostly based on small loads, not only to fit the slow manual applications such as beam work, but also because the pits could contain only a relatively small quantity of raw material. The small pit loads were loaded into paddles or drums where 1 ton was considered a big load. Paddles in particular were very labour intensive, loading and more difficult unloading being done by hand. Drainage was achieved by knocking out a plug from the side of the paddle and moving very quickly to avoid the rush of lime liquor that squirted out. Drums were difficult to drain. This key requirement today could only be done through a slatted door, which was substituted for the solid door during processing. Well, who can forget the job of ensuring this solid door was watertight, so chemicals were not lost? Rubber seals that lasted a few days at best, packing the door with leather shavings or cuttings of leather using wooden wedges to tighten the fit of the door that seemed to weigh half a ton itself. It is no wonder that workers were reluctant to take off the doors unless they were forced to. The owner of British Crown was very proud. His paddles and drums were more than 50 years old, still belt-driven. That's why I got that picture. You can see them in the background. This was actually the long gun at British Crown. And it was exactly the same as that in 52. The most hated task, apart from sealing the door, was to re-wax the leather belt to stop it slipping as it did regularly when it got wet from the float leaking out of the axle. The metal joint on the belt would rip into your hands if you were not careful, as you had to remove your gloves to grip the wax stick. All this was done while standing on a wet and greasy gearbox, with the drum turning very close to your head. With the demise of the beams, machines for unhairing, fleshing and scudding were installed, all with mechanical clutches. The operators could make the opening and closing of the rollers against a bladed cylinder into a continuous operation by skillful use of the clutch. This way they could work faster and earn more money, but at the expense of lost fingers if they misjudged. Tannery workers could be recognised for these sort of injuries, I came to realise. Tanneries were very dangerous places before the 1974 Health and Safety at Work Act. There have been many changes in the Beamhouse since these early days. Most should have been made earlier, but the whole area was in a time of time warp, but the wheel of pressure had been missing. I would like to discuss how these changes have transformed the Beamhouse and some of the technical problems I encountered during this period. In the years after the Second World War, in spite of serious economic problems in the country, the tanning industry boomed, but labour was short. The school leaving age had been increased to 16 and national service was increased to 2 years, both seriously reducing the pool of workers. This labour shortage and the need to reduce costs set in motion improved mechanisation during the late 50s, in particular the Beamhouse, where the issue was the most acute. Beamhouses were full of workers, as we have seen, each hide or skin being handled many times through the processing. So notable changes were made in mechanical handling instead of manhandling, using automatic dosing of chemicals and water instead of using buckets. Both developments have drastically reduced the workforce required. Proofread fleshing machines further revolutionized the Beamhouse, allowing 2 men to flesh over 2,000 hides without excess effort, and was a key reason why the 48-hour raw to wet glue process became normal procedure. Paddles and drums are the first to be upgraded. These were actually full production drums, half ton. And you can see here the slatted doors, as they call them, to drain with. And now you know why draining was so terrible. Paddles and drums were the first to be upgraded. The requirement was increased size, bigger the better. Bigger vessels meant bigger pack sizes, so increased production, which was the driving force. In many cases, however, the infrastructure around these new vessels was often ill thought out, with poor access for forklifts for loading and poorly planned systems for water and chemical additions. Bigger loads meant larger quantities of water and chemicals to add, but little thought was given to how this would be achieved. The main problem, however, was water supply. Often the big drums were fitted with the same 1-inch feed pipe typically used for the small drums. It would take an hour to fill the drum with water. As the process changed 4 to 5 times during soaking and liming, this made a 24-hour system impossible. Larger pipes and pumps secured the slow feed, but often the water supply was inadequate, especially heated water, making the installation of new storage tanks a priority. Tanners quickly found the cost of the new vessels' infrastructure was often more than the vessel itself, so infrastructure was regularly underfunded. The introduction of drums 5 metre by 5 metre and bigger into production was not without technical problems. The running speeds used in the smaller drums proved inadequate and left many hides with hair still on. The introduction of controls that allowed forward and reverse running improved this problem, but it was only when drum speeds were increased did we see improved results. Mechanical action in big drums was made worse by the tendency to overload them, leading to floats well over the axle. Working in a wet blue plant in Australia, I had to use a step ladder from the drum platform to look inside the drum during trials, as the door could only be opened when it was on top, or the hides would have fallen out. This was a regular production load, so I did wonder how often the hides were looked at on a regular basis. Again, the quality of leather from these overloaded drums was a big issue, with hair on hides being a regular occurrence. But productivity came first in this and many other organisations. The engineering of this equipment was sufficient for large loads, I was frequently told. The drums were developed for increased tonnage, so it must be okay. In fact, when pack sizes were reduced, quality was improved, but reduced loads meant extra drums being needed to hold up production levels. So again, productivity came first. Because of the cost of installing the new equipment, tanners were forced to use them at a maximum capacity to justify installation, almost irrespective of quality. I worked in South Africa, adapting the liming process from small drums to a 5.5 metre giant. The tannery planned to replace 8 2-ton drum loads a day, a normal daily production, into one jumbo load and increase production at the same time. The process we were using was well established in this company, so I expected little problem. But the load I was given, however, was too big for the drum, 25 tonnes. South African hides are lighter than UK at about 40 kilo each. It took almost 4 hours to load the drum, 600 hides or so by hand. We could not use a forklift, as the drum had been installed in a narrow passageway between the Beamhouse and tanning yard. In any case, before installing the drum, senior management, not technical people, had decided forklifts were not to be used on this new and expensive drum, as the drivers may damage the door. Labour to load the drum was cheap. We don't need forklifts, I was told. The drum manufacturer had given assurances the drum would hold 25 tonnes of hides, which I agree it could mechanically, but to soak and lime 25 tonnes was another matter. We had problems getting the full flow into the drum due to the overloading, but 22 hours after the loading had been finished, the drums were ready for possession. The drum door was open, the limed hides were simply dropped onto the floor as they had been from the small drum. The limed hides filled the whole passageway in front of the drum and slid, as only limed hides can, pushing the pallets that had been placed to control them into the tan yard, almost filling that as well. It took 6 hours to pick up the pile off the floor before we could reach the drum to start reloading again. The leather produced from this first trial, needless to say, was not very good, being very dirty and drawn. Eventually, the drum was repositioned and further trials with reduced loads was done, when it was found the most suitable weight that maintained the leather quality was 15 tons. This is typical of how they were first put in the big drums. So, tanners here would understand. The headroom. There's almost no headroom. It's about 6 inches from there. To load this drum, you had to build a platform here and load it by hand. To put chemicals in, you had to climb up here and feed it in through the axle. Some of you may recognise that because that's a UK tanner. It was. But it's very common. Mixers were introduced to the industry in the USA, transporting hides from the abattoir to the tannery, so allowing them to be processed at the same time. I was not sure if this project actually got off the ground, but mixers quickly became the must-have for Beamhouse production all over the world. First introduced into the UK in the late 60s, the reason for their instant success was the low headspace needed and the ease of installation, often wheeled into the factory and running inside a day. In old tannery premises with low roofs, as we've just seen, installing new drums that needed extra headroom was almost impossible. Mixers are still used in many companies in spite of the tendency to scuff the grain, as the drainage and unloading are far superior to other vessels. The automatic recycling of floats from the back of the mixer to the front gave such good distribution that reductions of chemicals was possible. Drum manufacturers quickly offered this recycling technique as the potential to reduce chemical losses was realised. In latter years, this recycling system also allowed hair-saving processes to be introduced, subject to adding a filter. Early work with mixers in the UK, however, was again blighted by overloading. Hides had insufficient room to open up when the mixer was overloaded, so tended to roll instead, leaving the inside of the roll with hair on. Once the load size was established, these vessels worked well in Beamhouse operations. However, I had the biggest trial disaster of my career, liming in mixers in these early days, again while working in South Africa. The company had installed a mixer for trials, and a process had been agreed based on the current system. I arrived at the tannery at 6 AM to find the mixer already loaded and ready to start. At first all went well, the hair came off and liming continued without apparent issues. The following day, after washing, the hides were dropped by putting the mixer into reverse. While the first few hides came out, the rest seemed to be sticking, so the mixer speed was increased to force them out. The rest of the load, 150 hides or so, came out rolled together in one sausage over 50 yards long. During the previous night, the fleshing machine had broken down, and workers had finished the remaining hides on a side flesher. This was green fleshing. The 25 hides that had been cut into sides had tangled the rest into a tightly rolled sausage. It took almost the rest of the day for the workers to unroll the hide, only to find inside the hair was still on. It took a further day's processing to remove the remaining hair, whilst having to listen to the technical staff question my parentage. Needless to say, it took many years and cost a lot of beer before this was allowed to be forgotten. The question of quality when systems and processes are changed has been an issue during the whole of my time in the industry. Considering what has changed during the last 50 years or so, it's no wonder. At British Chrome, processes were strictly controlled. The owner, a tanner all his life, had developed the original process himself and insisted changes were approved personally. In the owner's office was a big walk-in safe, not for money, but for bundles of finished leather, carefully wrapped up and labelled with the year of manufacture. These bundles were the standards to which all trials or process changes were compared. Of course, as these standard leathers had been produced during the 1920s and 30s with little restrictions on time or the amount of handwork involved, it was impossible to match the quality and stay within the cost restraints imposed during the 1960s. How in later years, during the time I was responsible for development, I dreaded the ritual of the senior people being summoned to comment on leathers produced with new ideas. These magic bundles of leather were fetched out of the safe, carefully unwrapped, and compared to the leathers produced in the trials. We were never even near the quality of these old leathers. So we're always asked very politely, please try again. And the standard leathers were bundled up again and put back into the safe until the next time. Blakey, in his Wolston Home Memorial Lecture in 1999, had touched on similar problems in his company. His words sum up the situation we both found in the mid-60s. Processing costs have reduced by installing new equipment that reduced labour numbers. But profits per capital invested are way down on former values. The quicker and less labour-intense processing has compromised quality in the sense of not utilising each hide or skin's potential. It was realised too late for British Chrome, I'm sorry to say, that it was impossible to continue with the traditional processing. Changes had to be made, and quality compromised a little or go out of business. Unfortunately, changes needed time in this very traditional tannery, and time ran out in 1970. A familiar story for many family-owned tanneries in the UK. Many times in my working life, I reluctantly had to accept economics of leather production came first and quality a clear second, although I and everybody who cares for the industry wished it didn't. As one tannery in the USA commented to a colleague, we don't make leather anymore, only parts for cars. Economics has made it impossible to produce the quality of leather in the safe ever again, which I find extremely sad. Processing time. Processing had to become quicker in order to stay profitable. The old system, where hides were left in pits for days on end, didn't fit into the modern approach that all industries were seeking. To quicken Beamhouse processing, mechanical action was introduced, so goodbye to the pits. New chemicals and techniques introduced that allowed changes in the old processing. Use less energy, less water, as this resulted in less effort. Reduce chemical wastage by being more efficient or recycling. This was the criteria. The Beamhouse produces substantial quantities of polluted water, containing not only salt from the curing, but dissolved hair and interfibral protein, as well as considerable quantities of lime, sulfides and other chemicals. This situation has deteriorated with the changes introduced, faster processing time, require increased chemical usage, and traditional processes use most chemicals in excess in any case. Because of the variability of raw material, age, sex, breed, curing methods, and length of time they have been cured, the real weight, normally the base for determining the quantity of chemicals to be used, is unknown, resulting in excess chemicals being offered, so ensuring sufficient for the task. Today's processing then, while being faster, generally uses more chemicals, so the effluent is more contaminated than before, but maybe in less quantity. Pressure to accelerate the Beamhouse process was intense. Tanners wished to turn over their money quickly, just like other industries did. This ultimately resulted in lowering of quality standards being accepted as a return for lower selling prices. Speed processing, if I may call it that, in the mid-70s went a bit over the top with the enthusiasm to produce wet blue in 24 hours. Started in the USA but quickly picked up by Herfeld in Germany in 1974, who advocated this was a way forward for European tanneries. For tanning from the rawhide to be finished in 24 hours, a quicker soaking and liming had to be created, as only 10 to 12 hours could be available for this section of the process. Traditional liming time was counted in days, not hours. Soaking even wet salted hides was a minimum overnight process. The development of enzyme soaking agents, which accelerated water uptake into the hide, had received little enthusiasm when first offered, mainly because of cost. Many companies had reduced their soaking time in any case with additions of surfactants and sodium tetrasulfide. So until the requirement for even faster soaking, driven by the 24-hour tonnage, enzyme soaking had little penetration in the market. Lieberfinger published a paper, Rapid Liming with Sodium Hydrosulfide, in 1975, in which he replaced the tetrasulfide and the surfactant with an enzyme on a surfactant carrier. The result was not only a quicker soaking, but by liming in the main soak bath and using low-swelling sodium hydrosulfide, a quicker penetration of liming chemicals was achieved, with considerable reductions in water use. The fibre separation, smoothness and cleanliness of the grain was comparable to the normal overnight liming. What spoiled this innovative approach when scaled up to production modes was the salt from the cure being carried over to the liming, interfering with the fibre swelling. The problem was, in Lieberfinger's process, the hides were ring-fleshed after a short soak. In practice, tanners tried to work without this extra step, as it was thought not to be necessary, but it did assist salt removal. I personally never saw quality leather produced from this 24-hour raw to tan wet glue process, except in very small scale. Once it ran in bulk, the process was uncontrollable. Corners often had to be cut to achieve the time scale. This resulted in hardly any soaking effect, so little removal of unwanted interfibre protein, no degree of fibre separation, and worst of all for a wet glue tanner, irregular penetration of tannage due to the poor opening up. This episode helped to spoil the reputation of some big tanners. One wet glue manufacturer asked me at the time if I could help produce a wet glue suitable for his own group's factories, but could then be adjusted for sale outside the group, using even less chemicals and less time. He could have also added less care. The problem was worse when dealing with wet glue plants set up by the abattoirs. Having limited leather-making history, the attitude was almost cavalier. It's wet and it's blue, so it will do, I was told by one company. The one good thing that came out of the 24-hour tannage development was that enzyme soaking became an acceptable auxiliary for most tanners and is the base today of most 24-hour soaking and liming process. There have been a number of changes of chemicals attempting to reduce the sulfide of lime in the effluent. Several process alternatives have been considered to replace sulfides of lime and produce a cleaner liming effluent. Aiming at mimicking the effect of old lime liquors, replacing some of the sulfide had successes, but carcinogenic fears reduced interest in this approach. Oxidation with chlorine dioxide also proved to give good results, but was hardly cost effective. Hydrogen peroxide with reduced sulfide offers was investigated with mixed results. The Darmstadt process developed the recycling of lime and sulfide after hair removal, but the capital cost was high and the process difficult to control in production. Experiments using ultrasound to assist the hair removal and opening up the fibre structure, also by accelerating the penetration of liming chemicals, have been successful, but not yet on a commercial base. Thiols, in particular sodium thiogallic acid, have proved to be an alternative to sulfide, but are seldom used alone due to cost. Its effectiveness in replacing part of the sulfide in normal liming processes has resulted in leathers with cleaner and flatter grain. Thiols are now used in most tanneries to reduce the sulfide offers. Enzymes, a subject all on its own, are biological catalysts and so influence the rate reactions take place, and as such has been seen as a saviour for low polluting hair removal and opening up for many years. Commercial enzyme preparations, however, are seldom pure and can cause considerable damage to the corium matrix, especially if there's been damage by bacteria. This has limited their use to date. Enzymes operate under a constricted range of conditions, particular temperature and pH. Transferring technology with rigid conditions of use to a Beamhouse, more used to using excess chemicals, can be fraught with danger. Even today, after many years of research, there is still no enzyme sulfide-free unhairing process that gives complete unhairing without affecting badly the leather quality. If I may add one last story from British Chrome days. In the mid-60s, we investigated the use of enzymes for hair removal. It shows you how long this enzyme story has been going on, mid-60s. A full paddle load was done, 300 skins, controlled by the chemical company's commercial representative, assisted by myself. And if you remember, I said earlier, technical people were not allowed in the British Chrome. The details are not clear now, but I remember the float temperature had to be increased from our standard 22 degrees to 30 degrees. Arriving the next day, the float temperature had increased to 31 degrees overnight. I tried to pole up some skins to see the result, and found to my horror the skins had been completely destroyed overnight, leaving small pieces no bigger than the palm of my hand. The skins we had used for the trials we had known were not the best and had some slight bacterial damage. And the enzyme, with the increased temperature, had accelerated the bacterial activity to a point where the skins had been completely destroyed. A matching load in the next paddle, processed with our normal process, had small amounts of grain damage, which was to be expected. We had found the reason enzymes have struggled ever since to be accepted. The hides need to be free of bacterial damage, difficult to achieve even today. Needless to say, our trials with enzymes were restricted after this result. The future. We must accept enzymes are unlikely to meet our expectations for cleaner Beamhouse processing, at least in the foreseeable future. Where do we go now? Discussing this situation with the research chemists at Chim and Tarlacker, it became apparent there is little on the horizon that is really new. An implication of the REACH project has reduced the likelihood of complete new technology being developed. REACH, for those who don't know, is the European Commission's chemical policy that revised the regulations on producing and using chemicals. The new system places an increased responsibility on the chemical industry to provide data, including recommended application, on all substances consumed, including existing ones. If the purchaser then uses products in a different way to that which it is being registered, a further evaluation and registration is required. An example to illustrate the difficulties would be a chemical registered for use in textile industry, which has similar technology to leather, must be re-evaluated and re-registered if required for use in leather. The product life cycle includes gathering and processing data from the extraction of the raw material to the disposal of the manufactured goods. The overall duty of care falls on the chemical manufacturer and downstream users to ensure their products will not cause adverse effects in humans or the environment under predictable use. This overall risk assessment or perfect safety approach will restrict development of new chemicals for the foreseeable future. The future then appears to me improved application and increased efficiency of the products currently in use, lime and sulfide. If we look at these chemicals with the new regulations in mind, the transport, storage and handling of both have minimal risk. We also find few hazardous byproducts when used in leather production. The chemistry of these chemicals are fully understood and they are comparatively easy to treat in the wastewater. There are issues with sulfides in the environment and wastewater treatments, in particular hydrogen sulfide gas, but these are not insurmountable. Lime, with addition of sulphide, guarantee a safe and complete unherring with a negligible list of residue hair. Prevention of chemicals entering the wastewater by cutting out chemicals altogether is not possible. But by optimising the quantities used, improving reactions with these lower offers, and improving application methods, then maybe it would be possible to make significant improvements with the chemicals we know. Where can we start? A number of ways are suggested in the so-called clean technology techniques. Water consumption. There is a case for saying that water is the most expensive chemical used in the Beamhouse. Not only is the cost of purchasing increasing rapidly, but also the treatment of the wastewater is becoming a major issue in tannery costing. All water use should be re-caught out, removing loose curing salt before soaking. With a machine like this, so reducing the salt carried over to the wastewater is a comparatively easy way to start. Work carried out many years ago, liming in the soaking float, was not pursued because of the excess salt in the soaking liquor. With the predominance of fresh or ice tides and the common use of desalting equipment, this work could be looked at again. Recycling of used Beamhouse floats has been a dream since my early days in the tannery. The use of part-old liquors in soaking, liming and baiting was common, but not to save water, but to improve the quality of the process. These old liquors would be used with fresh water to make up the required float. Work I have seen in production, reusing lime liquors after filtering or settling, causes a smell in the wet glue that is still apparent in the crust, so it seems to me not to be a viable approach. This area needs further development, but membrane filtration within the secondary treatment of wastewater shows promise if expensive. Green fleshing. It has been widely reported the efficiency of liming can be improved by green fleshing, but reluctance in the industry to handling the hides twice, also fleshing after liming, has meant little uptake. By green fleshing after the dirt soak and reweighing, we can ensure the weight of hides is correct, so offer accurate amounts of chemicals. The effect of green fleshing goes further than just removing flesh and fat tissue. It should be considered more of a breaking or opening up of the hide structure, thus subsequently allowing quicker chemical penetration and more uniform result. Dirt soaking and green fleshing should be carried out away from the Beamhouse in the hide store, so as not to compromise the time allowed for the main soak and liming process. The squeezing effect of the green fleshing improves salt removal, making liming possible in the main soak bath, offering considerable savings in water usage. Enzyme-assisted soaking. The importance of enzyme-assisted soaking cannot be overemphasised. These products accelerate the soaking, also assisting penetration of liming chemicals. The use of an enzyme in combination with a surfactant carrier reduces the quantity of chemicals needed due to the more thoroughly opening up achieved during soaking. The lime hides are smoother and cleaner and well-documented area gains. Hair saving is a substantial way of reducing solids in the effort, but it can also improve chemical efficiency by reductions in sulphides needed to pulp the hair. Most current hair saving processes use thiols to replace some of the sulphides. Thiols added before the hair immunisation stage will loosen the epidermis and partly attack the free keratin of the hair root without affecting the hair shaft itself. Environmental impact of thiols is widely understood, being a chemical used in the cosmetic industry for many years, and is considered a safe chemical, as far as that comment can be made. New vessels. These Cagaloni drums, this new drum technology is reported to permit increased load by improved mechanical action, creating a lower ratio of water to goods. In theory, this should permit chemical offers to fall nearer to the theoretical limits required to achieve hairy lubal and fibre splitting. The manufacturers also claim reduced energy consumption, so this approach offers many advantages, but it involves installing new equipment. So, are we back where we started? Not at all. We may continue to use chemicals associated with the industry for hundreds of years, but we understand more about these chemicals and their reactions. Beamhouse labour requirements are now low, and manual working hardly an issue. Manual handling hardly an issue. Enzyme soaking products have reduced both process time and overall chemical offers, making processing quicker. Atkin would still recognise the process being used today, 50 years after his death, would find the transformation of the Beamhouse genuinely amazing, as I have looking back over the last 55 years in the preparation of this paper. Thank you for your kind attention. I hope you all found something in my paper that reminds you of just how far we have come in Beamhouse procedures and technology. Thank you.
John, thank you for an absorbing talk there. I did recognise one or two of your observations from my mere 30 years in the industry, but I'm sure everybody's had a nightmare that involves taking the hides out of the drum with colour. I certainly have in the past. On behalf of the Society, thank you very much. I'd like to present you with a little memento of your effort today, and thank you once more. And then we'll ask if anyone has a question or two for you, if that's all right.